Hey all, so I'm here today to talk about warp logic, warp science, 7 point science. I call it 7 point science because it's the equivalent of taking three triangles and stacking them up in different directions to create a 6 point star, with the seventh point being the hollow center. So, easily put, it's a 7 point science. It's actually the science that goes into warp engines. Now, we always thought cryogenics would be the way of the future, but it's not. Fiber metal is this really important metal that comes from the metal of a dying star, like ancient stories tell us. The ancient stories that talk about Thor, that talk about Mjolnir, that have artistic paintings on large rock walls and caves with a feather helmet, and all of these ultra dense metals from a dying star. Now, a neutron star is very close to being a black hole. And the black hole is what we need to emphasize as what works as a warp engine. We're creating the seventh point. The hollow point that they call 0 point energy is actually the number 7. So you're going ahead 7, but you're seeking to become 0. And to become 0, you have to lose 7, but to ever get to 7, you have to gain 7. So the way mathematics of a warp engine actually functions, which is something I'm really passionate about, is that for every distance we're warping. For every time we go forwards, we're gaining one behind, and we're losing one in front. So if the destination is 100% there, and where we left was 100% a place but 0, we left 0 point. And we're going to get to 100. And as we transverse that 0 to 100, we're losing distance in front of us. The number actually grows smaller until it grows to 0. Meaning if you look at it, you have 100% of where you are, over 0% of where you are, to 100% of where you're going. And then once you're there, it's over 0%. You're going to be in a place where you have no more to go forwards or backwards, your final destination. Now that's a 0. You've closed the gap. So one of the easiest ways to look at this is, I can use this as a little bit of a graphic, is that if this is our warp ship and we're here, this is 0. We're not going anywhere. We're here. And it's 100% of where we are. Then as we travel or transverse forward, so we're warp jumping, as we go warp forwards, in front of this direction, we want to end up at 100% over here. And eventually, when we get there, even though it's happening simultaneously, we end up at a 0 point number. So we're going this way. And now we have, right here, we have, let's say, 99. And as we get closer, we're actually deducting the number. We're going down again to 98. Now we're moving forwards 97, 96, 95, 94. And behind us, from 0 over where we started, we're now gaining +1. We've gone +1 forwards in the prominent direction. Now this is really important to understand because this is how the ship actually functions. And this is the simplest mathematics absolutely possible, is that 100% of where you are and where you start, and 0 is the first number in the equation. Then as we travel forwards, we're seeking to end up at 0 over 100 because we want to end up at 100% of where we're going. And so one of the easiest things to understand is then we talk about metals. We need to have metals that can re-enter atmospheres. Ships have to be very simple in many ways, even though there's a quantum computer and a supercomputer, because a quantum computer node ends. What they say is we have 2 particles, and when we spin one, the other turns like a twin. And this is significant because this is the talk over 0. We're talking about the exact same things have to fully reflect from how we have love stories where problems become 0 to how we have warp engines where distance becomes 0. And then distance in a love story can become 0. And this is ultra important 7-point science is the belief that our love stories are simultaneously happening over the blank spaces, that term that we hear popularized by Taylor Swift. Well, a really deep contextual, philosophical, metaphorical way of looking at it is that that's how warp engines actually function. We're crossing over zero. We're closing the gap in love or energy. Love is energy, the way we experience it through our souls, through our beings. So the simplest way of putting this is that we have new metals. And these ancient stories, 15,000 years old, 12,000 years old, approaching the last ice age, 15 plus thousand years ago. These cave drawings, these paintings, these datable things say metal from a dying star. Now, metal from a dying star is simply put when a star gets so large and eventually dies, if it just doesn't have just enough mass to flip through itself over zero, because every star is a positive one to our universe. And a black hole is always the negative one bungee, so to speak. It contains gravity, and it pulls everything back in. So one of the hardest things to understand and one of the simplest things to understand is we had the Big Bang. And therefore, everything comes bursting out. And then as stars form, we have plus ones. So if you look at the Big Bang as 0 to 100, and it has to be both at the same time because 100% of the Big Bang already existed when none of it did. But it was happening at the same time. So the whole universe would flip through itself, meaning that, sadly put, we're not expanding forever. We do eventually contract, even though it's over billions and billions of years and reincarnations and simple science. It contracts through the black holes back down. Now, you could then see metal from a dying star as being very rare. Each star would contain different metals. The way that the star dies, leaving this metallic core that starts to spin very fast, or maybe it doesn't. Maybe the star just has this metallic core that doesn't spin fast like all the other neutron stars. But it quenches, the term quench, like when you take a sword and you put it in oil and it becomes stronger. Metal from a dying star, what we need for quantum spaceships, for spaceships themselves, and for the new re-entry metals, sheets that are very durable and can withstand massive heat, is the quench. It won't crack entering atmospheres. We can make probes that go down to the center of planets because if we know our metals can handle what a neutron star handles, which is the center of a star, it's that it takes all that heat, all those reactions, and it leaves behind the metallic dense core. Now, if it's not dense enough to flip through itself over zero and expand back out into a black hole, we have what is a metal, not a non-metal, but what is a metal from a dying star. Now, we can recreate metals from a dying star in laboratories that don't have to be too intense, but we can recreate what is, if we take some aluminum and particleize it, we take some stainless steel and particleize it, we take what is carbon and we particleize it, we can put them into cryogenic molds. Just like the cryogenic mold of a neutron star is deep space itself. As that star dies and the radiating heat all starts to push away, it's pushing because it's pushing out heat, and the cold is trying to get into the center of the metal. Those streams of liquid magma metal, it's magmatic metal in essence in the center of a star as it cools, is going to eventually densify, and it creates crust. We know that the center, like the core of the Earth, of a neutron star scientifically must be, because it is so hot, that when hot touches cold, and it creates that metal crust, what's inside is still going to either be spinning or be stagnant there, but it's going to be a liquid magmatic metal. Now, these metals create veins as they cool, and the quench, kind of like a sword going from 1,000+ degrees to the oil of room temperature, it's going to be that the room temperature is 0 degrees Kelvin. I believe the proper term here is Kelvin. Now, we're talking about negative 328 degrees Fahrenheit, and that's very cold, and it's quenching the neutron star. But those metals are so dense and so hard that we can have magnetic anomalies. These magnetic anomalies are so intense because the metal density. It's like taking a neodymium magnet and holding it in your hand, just a little disc magnet. Maybe it's only a centimeter across and it's a piece of neodymium magnet. Now, if that's coming out of metal from a dying star, and it's, let's say, the exact same metal, but it's cooling in deep space, it can quench under that gravity so intensely hard that the actual magnetism is way more than if we electrically amplify the neodymium disk magnet. Now, we can create through particleization and molding processes using lightning, so using Tesla towers and arcing in our lightning bolt. Now, when we arc in through a set of pins like acupuncture into these molds, the molds can be later stripped away by CNC. However, the metal inside is going to be so dense, all we have to do to make it nice and shiny and a perfect panel for a spaceship is to take a little CNC bit, and now we can create that out of fiber metal, and we can carbonize it. So instead of adding diamonds, we're adding carbon, which actually lessens the density. Because if we have a bit that can take away the steel mold, but leave the fiber metal inside, it'll wear itself out, leaving the panel there. And so we're creating re-entry model panels that can handle re-entry, like in spaceships and movies. Oh, wow. No more do we need to have the heat shield panels that can rip off in squares. No more do we need these things. It's truly an oh wow moment with much enthusiasm in the scientific community, but this is how the new metals are made. For years, I focused in meditations and such, and I realized that the simple science of Metal of a Dying Star, stories told in good faith and honor, blank space stories, would detail beyond doubt that these blank spaces can also do things that seem magical to us. Densities. So dense it's like a hammer could hold anything down and no one could move it besides one person. And I know how it sounds, especially to potentially the scientific community. However, Metal of a Dying Star explicitly explains the science of how we can make these spaceships. Superstructures so dense, yet we can create engine components that much more dense, meaning a jet engine could produce excessive thrusts. We're talking about ionization of lightning heat, so it creates what is like a jetted lightning. So what it is that we have a propulsion system like a jet engine. And in the rear, we can use what is arcing electricity that creates rapid heat. Now we're moving cold air in front of us, or cold, and we're pushing it out the back of the jet engine. And as it's going out, it's gaining heat. So a simple crab claw clamp on the back that pinches down the air adds the pressure going out the rear. So we're talking about thrust components that these jet engines can now lift NASA-sized rockets on jets. We're not talking about the old space shuttle program anymore. It's Metal from a Dying Star. And one thing I'm passionate about is science. And 7-Point Science explains that for every time we have all those triangles of magnitude, of magnetic materials in a neutron star that are so dense, we see these extreme results in our scientific studies. These new metals from a dying star, simply takes understanding something that seems like magic and understanding the blank space components therein. This object is either going to be so dense as a star that it becomes a black hole over zero, or it remains a 1 because the 1 actually has the components inside of it that is the metal itself. Now those metals, like I said, we know that a neutron star is so dense we couldn't even really cut it with modern technology. Diamond bits aren't going to do anything besides glaze up and sheen the outside. You're basically talking about that the bit'll break. And that's our best drill bits in CNC today. Now, it's almost impossible to go to that neutron star and to land on it and to then take metal from it. So we can recreate the metals in laboratories. The star itself particleized the metal. The metal was liquid due to heat density under all those nuclear reactions, fission, fusion, everything leaving it behind. Now what's left behind is all of this metal component and all the slag in it. It's all of that then hits negative 328 degrees Kelvin. And those Kelvin components that quench makes it so dense that if it was just a little more gravitationally dependent on itself, it could collapse in. And that collapse is a black hole. So if we need the black hole inside the center of our engine in a spaceship, we need to contain the black hole. Now, a black hole under containment is simply put that black hole must then have a field node system, a way to put it around a spaceship. So when we see UAPs, we're understanding the concept of UAPs as it's basically functioning as a black hole. It's allí aquí in Spanish. It's there. We see the object there. And it's important that we understand that object is right there. However, to the object, it's here. The object itself is here, and we're here. So we see the object as there, and the object sees us as there, meaning it can then take a 0 point in 7-point science and turn on a dime. And the gravitational effect inside wouldn't kill a human. Normally we have centrifugal force functions, and those mathematical functions of logic say that if you turn that hard, your body's going to liquefy into itself and therefore kill you, so we're limited. But with the allí aquí theory that I came up with, and I use those words because it's here and there at the same time, we're understanding that allí is where we are, and aquí is there. I'm sorry about the background noise. I'm in a public setting as I talk about science. I'm passionate about it, and I love to talk about science. But just so you're aware, I'm sorry about the background noise. So, allí aquí is the theory that I came up with. And again, I like to share it because it's a way of thinking logically past Einstein. Einstein mathematics of E equals mc squared basically states we have a Johnny Appleseed theory. We create this much gravity, and therefore it pulls and drops this much off. And that's how the apple falls. But allí aquí theory is that allí is where I am. And to a foreign object, aquí is where the object is. So I'm there and I'm here. I'm here and I'm there at the same time. And we have to see other things as here and there. UAPs are allí and aquí to the UAP. The 100 over 0. If you define the terms and cross them into a mathematical equation where aquí becomes aquí and allí becomes allí, we end up with 100 over 0 and 0 over 100. It allows us to actually understand quantum logic. Now this goes into how we can then model it into a quantum computer using sets of coordinates. Because the metal we know, if the metal can withstand the dying of the star and quench, then we know beyond doubt that quench just didn't become a black hole. But it could have with some more density, with some more gravity to the star. Now that's ultra important and simple to understand. So the thing that is this close to becoming a jetting black hole is the answer to those ancient stories, metal from a dying star, a star that dies. And if you could harness that metal, you would harness the most dense, heat-resistant, highly quenched, quality metals that flow in streams. It's like a vanic system. It cools down to the coldest space, but not all at once. It's cooling in different layers. It's cooling in different streams. It's creating shards of metal that we see through ancient studies, where now modern technology finds ancient pieces of metal buried that we know came 25,000 years ago in untouched layers like we find dinosaurs. And yet there's metal there that no ancient around that time that we knew metallic or metallurgy person invented. But we know that there was UAP stories. And so simply put, the easiest way to understand this is that we're allí aquí, the object of a UAP is allí aquí, and we have to understand that that metal is that simple. I talk about it and I'll say it a lot in repetition because it's understanding it's that simple. Metal of a dying star. Now, how did someone figure that out back then? These ancient stories describe it. They talk about these things very vividly, and it's very important to understand that. It's important to understand that the ancient stories of people on a planet that made handcrafted paintings in caves that seem modern to them back then, and to now we look at it as, wow, look at that painting, look at that art on the wall. Now that wall is that important. It's to say that the honor of those stories, the blank spaces of those stories, go back to Metal of a Dying Star. So if I could emphasize it and ask you all a question, how would you make metal from a dying star? Well, let's turn to nature. Space is nature. Stars are a part of nature. Black holes are too. So how would you make metal from a dying star? And I can explain it in more detail with the particleization, the way it falls in the cold cryo liquid, where we're not cryogenically needing to freeze people in space because we're cryogenically making the metals so they can handle warp. And this is just something that I urge you to understand, is to watch this video and to turn and to look at the simple facts. Metal from a dying star, that neutron star, that object that exists by nature. It happens whether we're there or not, so we can rely on it without bias. And so I ask you, how do you make metal from a dying star? And right in there is how we start the new emphasis on spaceships. When you realize we can make these metal components already and put them into jets that fly into space with simple heating coils that are running electricity through them in the jet engines, we then have the ability to actually fly to space in jets, fly to Mars, and fly back, and we're not flying rockets anymore. And this simple metal also can then be contained in the structure, and then we use other metal components to lighten the density of the overall structure. And so it's that simple. 7-point science is just simply the understanding of ancient stories. And I urge you all to really think about it. How would you make metal from a dying star? It needs to be vapidly hot. I think vapid is a good word there. Maybe it's not, but the metal has to be so hot in the star that it's the core. Just like the core of the Earth is described as being molten metal. So then we have that. Now, how do you quench it when the star dies? And you'll realize, well, cryogenics cool it down enough. And so what systems would you build in a laboratory to recreate the environment? Ultra-hot metal particles coming together, quenched down to no degrees in essence. And that's why I'm very passionate about it. I see the future of space technology being this simple. And I urge you all to see it as well. To have public space features, public space police ships. We're talking about air valves, that we could make X-Wings with air valves all underneath the body and the wings. And those valves could be so dense in metal compared to the rest of the structure, but so reliable and so good at torquing the air through opening and closing the valve that we could then fly a structure where that hovers and can go to space. It's possible to do these things now, and yet we don't see them. So, as a passionate scientist, I urge you all to understand that science is right there in your grasps, and to be careful, because cryogenic liquids could kill you. And also having that hot of density of lightning, millions of degrees, into an ice-cold liquid, because we're going to need a liquid in essence to harness all the particles into place, into the fiber metal. As we recreate metals from a dying star, we're starting with ancient stories. And it's as simple as thinking, what did they witness? And how do I question that into understanding the metals of dying stars? It's like reading Chariots of the Gods. And I haven't read the book myself, but if you could write another book in essence off of it, you could call it Metal of the Gods. The idea of these metals. And ancient stories of a flying hammer that says metal